something very big, a magnitude 7 earthquake, just hit one of the most isolated fault zones on Earth, guys. It has struck the South Shetland Islands, has nothing to do with the Shetland ponies, just off Antarctica. And even though almost nobody lives there, this is exactly the kind of place that grabs attention of many scientists, especially seismologists, because it sits inside a messy, powerful collision zone between two major plates. So this was not some tiny deep tremor that was hidden far underground either. It was shallow. It was only around 17 kilometers deep. That's roughly 14 miles, which means that it had the potential to move the seafloor and shake hard near the source. And what that means is even more interesting given the location. So the South Shetland Island sits between the Antarctic Peninsula and the Scotia Sea. It's part of the planet where the crust is being pulled. It's being shifted and it's being broken in different ways at the same time, all together. So when you see a quake like this, the first question is not just how big was it? The question is, what part of this fractured system just moves or moved? And what does that mean for what's happening next? So now the good news at first. As of the latest available information, this earthquake happened in an extremely remote marine region. The South Shetland Islands do not have towns or cities that are full of civilians. And you see this on the maps here with the population density that the USGS gives us. So there are research stations and like seasonal or year-round scientific crews, but no permanent like general population. That means the direct damage risk to like large number of people and in structures is dramatically lower than if the exact same quake had hit like Chile, Japan, Indonesia, or the west coast of Canada or the US. So when we hear magnitude 7, we always think like collapsed buildings and mass casualties, but here that is very unlikely simply because there's almost nobody there. But that doesn't mean that this earthquake is not interesting. So the real near-term concerns are different, like damage to nearby station infrastructure, dangerous local shaking, landslides to like steep icy slopes, and of course the question that everybody asks after a shallow sea quake is the tsunami risk. And this is where the story gets a little bit more nuanced. If we have a magnitude 7.0, the ocean does not automatically create like a destructive tsunami. We need to have a few factors that need to be right in place. So what really matters is whether the seafloor moved vertically enough to displace a big volume of water or not. So in this region, the broader Scotia and Arctic boundary, it's often described as, we can call this mainly transcurrent. So basically it has a sideways motion, and sideways motion is generally less efficient at generating major tsunamis than classic megathrust subduction quakes where one plate subducts underneath the other. But the South Shetland area is not purely strike slip like the San Andreas fault, like strike slip. It is tectonically mixed. So with the trench and the Bransfield arc system, like the back arc system, also being in place there, it adds to the complexity of this area. So you can never dismiss a tsunami potential without checking the source mechanism and official monitoring. And that complexity matters because this region has a history of significant seismic unrest. You see it at the maps, like all the white dots is like the historic seismicity. So there's studies of the South Shetlands and the Bransfield Strait, and they show that the area is like a natural earthquake prone area. And scientists have also documented major recent swarms in the broader region that is around this epicenter, including like the extraordinary primary earthquake swarm that happened there in 2020, 2021. This was associated with the deformation near the Orca Seamount and the Bransfield Basin structures. So in other words, this is not a random like dead zone that is suddenly waking up. This is an active, restless plate boundary system. So the question is, which fault or zone has likely moved here? So based on what we see on the map location that the USGS has given us and the regional tectonics that are in place there, this quake appears to be tied to the southern side of the Scotia system near the South Scotia Ridge, South Shetland sector. It's basically where the Scotia Plate interacts with the Antarctic Plate. And that broader boundary is mainly transcurrent, but near the South Shetland margin, it blends into a little bit of a more complicated environment, and it involves the old Shetland Trench and the active deformation in the Bransfield Strait. So the honest answer is this: it was almost certainly part of the Scotia and Arctic boundary system, but the exact fault style needs a reviewed focal mechanism before anyone can speak with full confidence. So a lot of people oversimplify these events, right? And say it's just one big fault, but it isn't, right? This is one of those places where Earth is like tearing and sliding in stages. So you have an old subduction history, you have present day lateral plate motion, local extension, we have volcanic influence in parts of the region, and frequent seismicity that's all layered together. So this is why a quake here is scientifically fascinating, even if it causes like little direct damage. And I have not found anything when we speak of damage, like any reports that are yet showing significant destruction or anything else. And again, given that this epicenter is so remote, major damage is not what I expect at this point. But I want to be very precise here, guys. That is an informed assessment based on location and exposure. It's not a final official all clear yet, right? In a region this remote, hard confirmations can also lack, right? Makes sense. Population's tiny in global standards. But here's what I would watch next. First, aftershocks, right? Magnitude 7 shallow earthquake should be expected to produce a sequence of aftershocks, and some of them can still be strong. Second, if the agencies publish a focal mechanism that shows that it's mainly strike slip motion or something with more vertical displacement. Third, is there any Antarctic stations or Chilean monitoring bodies that report unusual wave activity like tsunamis, right? Infrastructure issues or like ice slope instability. Those are the next clues that will tell us whether this was simply like a powerful remote plate boundary release or something with broader implications. The existence of frequent seismicity in the region makes aftershocks very plausible. And one more thing, you might ask, well, is there a volcano erupting? In the South Shetland region, there are volcanic and magmatic systems, and past swarms in nearby parts of the boundary have indeed been linked with magmatic intrusion. But like a single large tectonic earthquake like this does not automatically mean that an eruption is beginning. We've seen this in Kamchatka after the megathrust earthquake 8.8. We did have volcanoes erupting, but I don't think that we can expect that with a high probability here right now. So that would require like separate evidence, like is there a volcanic tremor, is there deformation, is there gas changes, or is there's a swarm now located specifically near a volcanic center. Right now, the stronger case is that this is a major tectonic earthquake in a geologically messy, active boundary zone, and the USGS has it somewhere between 6.6 and 7.0 right now. Other stations have it at 7.0, but we will see. I hope you found this interesting, guys, but check out, there is more. There's this unusual pulse that happens to Earth every 20 seconds. And no, this is not the Schumann resonance that many of you commented. Watch this. It's really, really mysterious. What is it? They call it the Earth's heartbeat. Very, very strange. Scientists are giving us some potential explanations, but do they really fit? Do they convince you? Watch this, because I'm not so sure. See you there. Oh, and please hype and like this video. Thank you so much. Bye-bye.